Okay, today I'm going to be comparing two GPS denied navigation systems. One is using ultra wideband technology, and the other one, LiDAR. So first we're going to get into what each of these things are. So ultra wideband technology, um, it is a form of navigation that uses external sensors to be able to tell where the drones are. And then there is a small transmitter slash receiver on board of the drone or other item that you're trying to record where it is, to be able to communicate with those sensors back and forth, to communicate its position and um, like yeah, where its position is in a 3D space. This is used a lot for swarm flying because it's fast and stable, and pretty accurate in a small area, and it doesn't use a lot of processing. There's not a lot of modifications you have to do to the drone itself in order to make this work. Lots of it's done outside of the drone with those sensors. Um, so pretty much what you can think about with it working, if you've ever used a VR headset that has external sensors, it works a lot like those, where you have the sensors placed around the room in various areas, and then they send a signal to the receiver slash transmitter on the drone, which then communicates back with the sensors to tell them where it is in space, and then it can use that data to navigate the drone. So it's very fast, very stable. As long as you have enough sensors, you don't really have to worry about it cutting out, even if it goes behind like a pillar or anything like that. So it's very good for indoor navigation. The next one that we're going to talk about is LiDAR. So LiDAR, it uses laser light waves to map out the world around it. So it generates cloud points. So it just has one sensor on the drone that will send out these light waves that bounce off of things and then come back, and the sensor picks up those again and can tell how far away objects are based off of how long it takes that data to get back to it. So the best results with this is if you have a two sensor system on it, one going horizontally and one going vertically, so that way it can tell more accurately where walls are and how far away the ground is from it. And what's really cool is it builds a map as it goes along, so that you can see the world around you. This technology is very up and coming. It's still getting figured out and getting honed down to be able to use easier, but it can be used a lot in like search and rescue and stuff like that. Um, or like in other situations to map out a building. I can think of like in like a hostage situation, they can send in this drone first with a LiDAR, and it can like map out the building, tell where all the building or where all the structures are and any potential people, which I think is really cool technology and like a really cool application for it. Or like going into dangerous situations like at a power plant, a nuclear power plant, if there's like a meltdown or anything like that, it can be used to um, go in first and like map out the building for those coming next, or like figure out if things are out of place or anything like that. So kind of to compare and contrast both of these, there isn't a lot that's super the same with both of them. They both compute your location based on time. So the LiDAR, it sends out a laser which bounces off of things, comes back, and then it uses that time to be able to tell how far away that object is. Where the ultra wideband, it has the signals come out from the what are they called? The transmitters. It's not the term that they usually use, um, but the ground units the sensors. It sends out a signal from the sensors, which then hit the little receiver on the aircraft and then come back to the sensors. And that's how it transmits data back and forth, and it uses that time to be able to tell how far away it is from those sensors. And both of them make a map to extent. LiDAR more so makes a map of the world around it, where with the ultra wideband, it makes a map of where the drone is and where it has moved and will move. So it's more of a confined map. But some things that they have differently, the LiDAR has all the sensors contained on board, where the ultra-wideband needs external sensors to work. The ultra-wideband has a shorter range of use because you have to set up those sensors, so it has to be confined in that area, where the LiDAR has no real limit to its use because it kind of maps as it goes along and builds this map so it can just like go forever as long as it has the battery and the processing power to keep going. The LiDAR is accurate up to 1.5 centimeters, where the ultra wideband is only accurate up to 10 centimeters, so it's not quite as accurate. The LiDAR is very data dense, which contributes to the next thing of them having a high onboard processing for the LiDAR. Because it is so data dense, it has to have a lot of computing power to be able to make the maps as it goes along and to calculate all of that, where the ultra wideband, it's very low onboard processing, so it like most of it's done off of the drone on like a computer or something like that that's external. So not a lot's going on the drone, which also makes it lower power consuming, where the LiDAR is heavier power consuming, uses up a lot more power. And the LiDAR is just a big sensor on it, where the receiver transmitter that's actually on the drone for the ultra wideband is just a small receiver. So, I mean, they're both very useful, but for different things, depending on what you need done. So, very cool thing. And then here is my reference page where I got all the information and pictures and so on and so forth.